All right, my friends, well, in this video, we're going to talk about how to do definite integrals using a u substitution. So let me just go ahead and start with an example, and we'll talk about what this is going to look like. So we're still integrating something that a u sub hopefully should be obviously the choice for. But in this case, we're going from 0 to 1. Okay, now when you look at this integral, my hope is that you will look at this and see I have something raised to a power. That's what I'm going to choose to be my u. Okay, so I'll take the derivative of that. The derivative of that is 4x dx. So I feel like I'm chilling, right? I have an x dx, so I need to put a 4 here. I'll balance with the 1/4 in front. So that allows me to rewrite this as 1/4 integral 0 to 1 of, okay, and the 4x dx becomes a du, and that's a u squared. But there's an issue here, right? And there's a big issue, actually, because these bounds are in terms of x. That's not cool. If I have an integral in terms of u, but the bounds are in terms of x, that's going to cause problems. So what I need to do with a definite integral is I need to change the bounds to be in terms of u. And the way I do this is I just write a little table. So my old bounds were going from x equals 0 to x equals 1. And what I'm going to do is I'm going to plug them in the equation for u. So I'm going to plug in your equation right here. So if I plug in x equals 0, that's 2 times 0 squared plus 1, that's 1. When I plug in 1, I get 2 times 1 squared plus 1, that's 3. So I don't want to write these in terms of x. I want to write them from u equals 1 to u equals 3. Now, here's the beauty of this method, is that you don't actually need to go ahead and change it back in terms of x. So I could just write this as 1/4 times u cubed over 3 going from 1 to 3. So that's 1/12 times u cubed going from 1 to 3. So that's 1/12 times 3 cubed is 27 minus 1 cubed is 1. So that is 26 divided by 12. Okay. So that's how you do a u sub. And again, the real key here with the definite integrals is now we just have to change the bounds to be in terms of u. Bounds of x will not work. It's going to make your life so much easier and take off a lot of work if you just put them in terms of u. And this way you're mathematically correct, right? If you write an integral in terms of u with x bounds, that's just wrong, going to cause problems. Okay, let's look at a couple other examples. Suppose we have to do the integral from 1 to e of ln of x over x dx. All right. Now, if you want, go ahead and pause the video and guess what the u is going to be here. See if you can work that out. All right. Well, I'm thinking this, like u equals x, but that doesn't really help because it just gives you like du is just dx. It doesn't help with the ln of x. But what if we choose u to be the natural log of x? Well, then the derivative of ln x I know is 1 over x. Ooh, I have a 1 over x dx. Saucy. So I'm going to turn this into, okay, and just the ln x, that's u. So I'm integrating u du. Now, I do want to change the bounds here. I have x, I have u. My x is going 1 to e. So I'm taking the natural log of 1, which is 0. Again, I'm plugging into this equation here. And here my u is the natural log of e, which is just 1. So this just becomes integral 0 to 1 of u du. And now that works out really nicely because that's just u squared over 2 going from 0 to 1. So that's just 1/2 minus 0 or 1/2. Okay, so that's how you will do a definite integral like that. Let's do a type of problem that's a little wonky. And this is something that you guys are going to see on the AP test with just some complicated ones with an f. So I'm going to tell you this now. Suppose that big F of x is an antiderivative. Suppose big F of x is an antiderivative of little f of x, so using the normal notation. If I tell you a couple of values, that big F of 0 is -2, and big F of 12 equals 8, I'm going to ask you to find the integral from 0 to 6 of f of 2x dx. Now, when you look at a problem like this, not f of x, but f of something else. I don't know why I wrote 3. This is just an example. But if you, I guess it's the third example. But if you see something in parentheses of your f, pick that to be your u. So pick u to be whatever's in parentheses here. So I'm going to pick u to be 2x. And then the derivative of that is 2 times dx, of course. Okay, so I need to put a 2 here. I need to balance to the 1/2 in front. But I also need to change the bounds. Right, so x is going from 0 to 6. I know my equation that u equals 2 times x. 2 times 0 is 0. 2 times 6 is 12. Okay, So this becomes, let's see, so now we rewrite this all in terms of u and include the bounds. If you don't change the bounds, you're going to be in trouble on this. Okay, so when I change the bounds, this becomes 1/2 integral 0 to 12. And again, those bounds are u equals 0 now. F of u du. Okay. Now let's give this problem a big fu. We need to get up to the big F, right? When I integrate little f, I get to big F. So I get 1/2 times big Fu going from 0 to 12. So this becomes 1/2 times, in parentheses, big F of 12 minus big F of 0. Now, those values are given to us. We know what those are. Outstanding. So this just becomes 1/2 times 8 minus 2. So that just becomes a 5. Okay, so that's how we do a problem like that and find the integral. Make sure you're careful with the concept with the 1/2. Make sure you change the bounds. That's something you always need to do on any kind of u sub with a definite integral. Okay, so that's definite integrals. I hope that helps, guys. Bring me some questions to class. I'd love to help you out. I'll see you soon.